So again, for the new kids, remember one thing. I'm an old man. I might take some time to memorize your name, but if I call you by a wrong name, don't feel bad about it. Okay.
Okay. Okay.
And I'll probably keep asking you your name one more time if I keep forgetting it. But it'll just take me a week or so to get familiar with the names. Okay.
Okay.
Yeah. All right. So here in the class, you guys can see me, you can hear me, and whatever I do, that gets recorded and goes to the YouTube. It's only for you guys. I don't want subscribers. I don't want a lot of people to like me and make me as internet sensation. This is only a reusable artifact for you guys to consume. Okay. So what I mean by that is, you don't have to be busy taking notes while I'm teaching, okay? Focus on understanding or grasping the concepts. That should be your primary objective, alright? So don't stress out yourself that, okay, I missed something, maybe I'll forget. Don't worry about it. After the class, I upload the video, and that you can always refer to. As long as you're able to follow me, as long as you're able to understand the concepts, this video is always there for you to catch up on whatever you believe you missed, okay? Alright, so let's look at what are the things that we wanted to cover. And let me go back to the...
Can we choose?
No.
We're already choosing the...
I have sent the topic, okay? So remember one thing, no wastage of time by getting into a discussion that is not needed.
We're already learning about probability.
Put it there. So we are going to talk about probability. We talked about probability in the previous class. And then we are going to talk about experimental probability, and I have sent few questions that we will practice in the class so that we get used to what probability means. Okay? So, for the kids who have been in the class before, they have gone through or they have touched the tip of the iceberg where we talked about probability. So, for the new kids, say your name one more time. Sandrine and?
Celine.
One more time. Suleen?
Yeah.
Sandrine and Suleen, okay. Sandrine and Suleen. That's how I'll pronounce it, even if I'm saying it wrong, the most authentic Indian way. Please excuse me for that, okay. Sandrine and Suleen. So now, since this is first class for you, Sandrine and Suleen, and I'm talking about probability, before I go deeper into it, what is your understanding of probability? If you have to explain that to me, assuming I'm a 5-year-old toddler, how would you explain probability to me? Don't think about math. Think about scenario.
It's like a scenario where things could vary.
Mm-hmm.
Yeah.
Okay. No, and this class is meant for making mistakes. The person who makes maximum mistakes learns the most. Not mistakes with respect to discipline, mistakes with respect to solution. I have some kids in the class who make more mistakes, which is non-math problems, okay? So, okay, coming back, guys. When I'm pointing at you, you are repeating the same mistake, assuming it's somebody else. It's you. It's you. Okay, coming back here. So, if I were you, and if I had to explain somebody about probability, my basic approach would be, see this coin. If I toss it, I might get a head or I might get a tail. Likewise, if I roll a dice which has 1 to 6 written on all the 6 sides of it, I don't know whether by rolling it I'll get a 1 or I'll get a 2 or I will get a 3. It's all equally possible. So, what somebody will get in an unknown situation is called probability. That's a chance or a likelihood of something happening. So, when I'm tossing a coin, if I'm tossing a coin which has head on one side and tail on other side, nobody can predict with 100% guarantee that by tossing a coin, it will be head or a tail only. Both are equally possible, so that's what is given as probability. Okay, chance of head happening is 1 out of 2. Chance of tail coming is also 1 out of 2. Now you'll say, why so? Hey Ritika, it is the way probability is defined is this. chance of a particular event versus the total number of events. So when you are tossing a coin, you can get a head or you can get a tail. So total number of chances are 1 plus 1, 2. What is the chance of head coming? 1 out of 2. Head, when you are tossing a coin, you cannot get 2 heads, right? You can only get 1 head. So 1 out of the 2 chances that you had. Likewise, when you are talking about rolling a dice which has 6 sides to it and 6 numbers engraved on all the sides. So you can get a 1, you can get a 2, you can get a 3, you can get a 4, you can get a 5, you can get a 6. What is the possibility of getting a 2? So possibility of getting a 2 is only one event. And that is out of how many? 1, 2, 3, 4, 5, 6. So that is how you say when you are rolling a dice, possibility of getting a 1 or a 2 or a 3 is 1 out of 6. Does it make sense so far, or I'm just blabbering to myself?
It makes sense.
Okay. How about you, Ritika? Smarni, clear? I'll keep on randomly calling out names, okay? Just to make sure that, no, you will make things more muddled if I ask you. I know where I have to ask questions to whom, okay? So, alright. So, this is the basic of probability. Now, if I say, I have a dice that I am rolling, which has 1, 2, 3, up to 6 written, okay? If I say, what is the possibility of getting a number more than 3? A number more than 3. I will not entertain any discussion unless I see you scratching something on your notebook. Yes. Sandrine and Sulaim. Did I say it right this time?
Yes.
Okay.
What half? Because 3 is
No. Okay. I got the answer. I'll come to you to explain. Same thing?
6.
Okay. Alright. So again, I'm repeating my question. I have a dice which I rolled. What is the possibility of getting a number more than 3? I got 2 answers already. Eventually both are same answers. Anybody else on the screen? Myra, Dikshita. Anybody can? Thanu. Yavihan. Arihan, sorry.
I got 50% chance.
Okay. How about you, Sandy and Tulin? You were saying something. And all of a sudden, all the kids disappeared from the screen. Everybody has turned off their video. Request you guys to keep your videos on. That makes you more comfortable as a teacher, okay? Yeah, Sandy and Sulin. Tell me better.
Like 1/6 of a chance.
Okay, think about it. I'll come back to you guys. Good that I'm getting different answers. I can choose between multiple answers. Yes, Dikshita, what is the answer?
I go 1/2, sir.
1/2. How about you, Ritika?
Yeah, like 1/2 or 50%.
How about you, Lakshita?
1.5.
Myra?
I got 50% chance.
Tanu?
1/2.
Yeah. How about you? Yeah, Hanin Sulin. Yeah, go ahead.
I think it'd be 1/2 too.
Yes. So again, as you all said, I don't have a way to contradict you guys now. If everybody in the world says 1/2, I might lean towards that answer, but I would still do that in my own way. One more time. The question is this. This question says, I have a dice to roll. What is the possibility of getting a number more than 3? So essentially, we are only talking about a situation when it gets a 4 or a 5 or a 6. That's the only situation when it gets the number more than 3. More than 3. Remember that, okay? So 4, 5 and 6. There are 3 situations. So I had 6 possibilities. So my total number of possibilities. Again, Probability means probability.
Probably.
It's not an English class. My pronunciation could go wrong. That's okay. Probability. Okay. Whatever it be, is equal to.
Chance.
Probability means likelihood of the event by total number of events. Now, hand down. Here, the question was, what is the possibility of getting a number more than 3? That means we are only considering 4, 5 and 6 scenario. So we are talking about 3 situations. That is my likelihood. 3 situations, 3 occurrences divided by total number of possibilities. 1, 2, 3, 4, 5, 6. I can get any of these numbers. So my total number of possible options are 6. Total number of options are 6. Total number of possible options are 3. So this becomes 3 by 6, which turns to 1 by 2 or 50%. All the answers are correct. What is it?
So when you say that has to be more than 3, it's not including 3, but it's going there. So if you said 3 or more, there will be a line over it.
I did not say that, right?
No, it's like this.
I did not say that. Did I say that? No. Keep it down. So don't get into a discussion when this discussion is not needed, because that will waste everybody's time, including yours. Okay, that's not good. So here, this is one situation. Now, if I treat that question like what Arab was saying, that if I say, what is the possibility of getting number 3 or more? That is when I am saying more than or equal to 3. When I say more than or equal to 3, first you write the expression correctly. I am talking about more than equal to 3. If I say this, then I am including 3 as well. Now my total number of situation that I am interested in is 4. So this becomes 4. My total possible options still remains 6. I am not going to get any number apart from these 6. Okay? That is how it is. If somebody says, what is the possibility of getting a number less than 2? Less than 2. What is the possibility? What is the probability of getting a number less than 2? What is my probability here? Tell me.
106.
1 over 6. Correct? So, again, probability is not something that is as complicated as it looks on the outlook, but it is all about how you relate to it. And keep this thing in mind. One is, how do you define probability? Probability simply means a chance of an event that you are interested in versus the total number of events. That will be a mathematical formula. Just keep that in mind. Okay? Now, there is something more than this. Now, this is all that we are talking about is theoretical. It's all theoretical. Correct? Meaning, if I toss a coin, I can get a head or I can get a tail. Both are equally probable. Both the probabilities are same. If I toss the coin 3 times, what will happen? Now, hear the question clearly and then answer it with a very thoughtful response to it. Again, we all have seen what happens when you toss a coin, right? I'm saying, when I toss a coin 3 times, what will happen? Let's see, what are the guesses that I'm coming across?
So should we give like the possible outcomes?
Yeah, whatever way you want to describe. Yeah, Pranam.
One's gonna be more likely than the other because you only flip it 3 times.
What is that?
One's gonna be high. It's gonna have a higher probability than the other because you spin it 3 times.
How about 50 times? I'm trying to make your life a little more complicated, Pranam.
I'm done. So it will be head, tail, 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 head, tail, head, tail, head, tail, tail, head, 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 tail.
Oh,
head,
okay.
tail,
I think you are going a little too far. I'll come to that one. That is important, but I'll come to that one a little later. But my question here was, I'm trying to navigate you guys in a certain direction, okay? That when I'm tossing the coin, let's see what Arihan has to say. So again, I'm just repeating my question before I let Arihan talk about it. I'm saying that mathematically I know that if I have a coin to toss, I can get a head or I can get a tail. And both have the same probability, 1 by 2, 1 by 2. I'm saying, if I'm tossing the coin 3 times or 5 times, what would happen potentially? And I'm more interested in a discussion than any mathematical solution right now, to see what our approach would be. Yes, Arihan, now tell me what you want to share.
So I think like you're likely going to get 2 or 1, for example, 2 tails, and then the other one has to be 1, like 1 head, or it could be the reverse. But there's no guarantee that you're gonna get 2 tails or 2 heads.
So, is there a way you can give me an assurance that you will not get 3 heads or 3 tails either? Yeah.
Yeah, you could also get 3 heads or 3 tails, but.
Right. So, let's see, Sandrine and Suleen, any thoughts around this one? And again, it's a very free flow discussion, okay? I'm trying to get everybody's point of view here.
I think that you would possibly, it depends on how many times you spin the coin. So if it's 3, you could get like 3 tails, 3 heads, or like 1 head and 2 tails, or 1 tail, 2 heads.
So, the direction in which I'm trying to guide you guys is this. There's a difference between theoretical probability and experimental probability. What I'm trying to mean by that is, it just gives you in theory that what is the possibility of a certain event's occurrence. However, when you actually do that activity, your result or outcome could be way different from what you mathematically thought. And that is why there are two different flavors of probability. One is called mathematical probability and other one is called theoretical probability. Now, mathematical, which is theoretical, and experimental probability. Now, Lakshita or Myra, tell me, what would be your going in position when anybody talks about experimental probability? What would be your story around that? How would you explain that? Lakshita or Myra, Asmarni. No, are you Lakshita? Are you Myra? Are you Asmarni? Then?
Are you a girl?
Don't take it far. Okay, so anybody, tell me, if somebody says, I'm talking about experimental probability, what does it mean actually? Not you. I called out some names. Yep. Sandrine and Suleen also, you can give it a shot. Let's see.
Wait, can you see the question again? I had the answer, but then I just forgot.
Now I'm saying, if you ever come across a term, experimental probability, what comes to your mind before you thinking about the math part of it?
When I think of experimental probability, I think like basically you can just like guess and like experiment with like a number. It's like experimental, so
So only one word that you might want to do away with would be guess. There's nothing called guess when you talk about experimental probability. Okay, let's see what Dikshita is saying.
I think the experimental probability is like based on like the data, like what they gave us.
Okay. Yeah. Pranav, any thoughts on this?
Experimental data is
Okay.
when you use data to find the probability.
Okay. So Ritika and Smarni have been very quiet today. Any thoughts around that, beta? Yeah, Ritika.
Wait, is it like experimental probability or like data? It's like
Experimental probability.
wait, so like is it like there's like a chance that like any like random event that will like occur at like sometime like
Right.
that would-
Yeah, go ahead. Sorry for interrupting you. Yeah.
So like it's like the probability that like something will like occur.
No, so we are talking about experimental probability, meaning, okay, let me not open my cards. So, no, you cannot force your answers on me, beta.
Okay.
Put your notebook down. I will not let you answer or not even ask you question for next 2 weeks, and I'll send a message to daddy saying, okay, I will not let person A answer in the class. This is just a reminder for him to avoid certain things. If I'm not coming to you, that there's a reason for it. Okay? So don't try to bypass that and force it on me. Okay? Alright. Yep, Arihan.
I was just gonna say, like, theoretical would be like you have like for example, if there's like a bag and there's 10,000 marbles and 5,000 of them are green and 5,000 of them are blue.
Okay.
In theory, you would half of the time you would be getting green, or half of the time you would be getting blue. But that could like vary.
Okay.
And,
Yeah. So let's come to a guided direction on this one. I heard everybody. Now you guys had different point of view, more or less converging towards the same concept. But let's be very explicit. If we say mathematical or theoretical probability, it's what we have been doing so far. It's based on mathematical calculation. But does it guarantee anything? No. It might so happen that I take a coin, I keep tossing it 100 times, I might get head 99 times and tail only 1 time. Very much possible. There's no guarantee, yes.
So theoretical probability is like when we were doing like this dice, what's the probability of getting over 3?
No, so let's make a solid wall between theoretical and practical probability. So I'll tell you why I'm doing so. This is theoretical probability. Okay, a hypothesis like what you had written. Theory is theoretical probability, and this is my experimental. Theoretical probability, let's say if I'm talking about the tossing of the coin with head or tail, it will say if I'm tossing it 3 times, okay? What is the possibility of getting a head? Listen to the question completely before you jump to the answer, okay? What is the possibility of getting a head in the first, second and third attempt? I'll say first attempt 1/2, second attempt 1/2, third attempt 1/2. Are you going somewhere?
No.
Why are you rushing for it then? So, what is the possibility of getting head in all the 3 attempts? It will always say 1/2, 1/2, 1/2. Now, experimental probability has no math to it. It says just do it, record it, and draw some interpretation from that.
Like science.
So here, it will say experimental probability is okay. I will toss the coin 3 times. First time, I got a head. Second time, I got a tail. Third time, I got a tail. See? Now here, if you look at the probability of head, it was 1 out of 3. Here, it kept on giving 1/2. So that's the difference. When you try predicting the occurrence of a certain event based on your data, that is called theoretical probability. So that is called experimental probability. When you just go by the concepts of probability and then you try deriving the occurrence of a certain event, that is called theoretical probability. Does it make sense?
Yes.
Everybody? Myra has not even talked us or told a single word, and she knows right after the class I'll catch hold of her. She is my daughter. So now the question to everybody here is, have you guys understood this? The basic difference between theoretical probability and experimental probability.
Yes.
Yeah.
One line interpretation is, if you are trying to derive the possibility of an event based on data by extrapolating it or interpolating it, that is experimental probability. If you are trying to derive probability based on the concepts alone without having any direct connection with the actual events records, that is theoretical probability. Now let's jump on to some questions. That is the only way you can appreciate all the blabbering I was doing for last so many minutes. Let's look at some questions. And this will be the chance for everybody to actually test your understanding and see if we know how to solve things or not.
Can I go to the bathroom now?
I mean, I'm sure there is nobody in the bathroom. Probably the bathroom door is locked. Some kid from the previous class would have locked it.
I think Dash did.
I mean, I don't know. I would not name
It
it.
was locked.
Yeah, so it is locked. So I don't think anybody is using that one. You have to hold it then. Or if you are in a desperate situation, then you have to go upstairs. You know how to go upstairs? Yeah, okay. So under that corner, right next to the pool table. Okay, guys, just give me 1 second. I'll come back. So these are things you should not be planning, okay? Math class is only for doing math. Don't plan keep this to the bathroom. Alright. Sorry for making you guys wait. So now what we're going to do is jump on to a few questions. We'll try solving it together and then we'll see if whatever we know is reasonably right or not. Now, I'm reading a question for you guys. Hear me out clearly. Carefully. Elizabeth is going to flip a fair coin 100 times. Elizabeth is going to flip a fair coin 100 times. What is the best prediction for the number of times that the coin will land tails up? Don't focus on that, focus on the question. Elizabeth is going to flip a fair coin 100 times. What is the best prediction for the number of times that the coin will land tails up? Now let me get the, guys, don't rush. Let me write the question clearly first. Pranav, don't hurry. First answer says exactly 200 times. Second option says close to 200 times, but probably not exactly 200 times. Third option is exactly 50 times. Fourth option is close to 250 times, but not probably exactly 50 times. Okay? So now let me read this question one more time. Are you with me in the class or you are making my picture?
I just put the answer D.
So here, The question I'm reading one more time says, Elizabeth is going to flip a fair coin 100 times. What is the best prediction for the number of times that the coin will land tails up? Choose one answer. There are 4 options given. Exactly 200 times, close to 200 times but probably not exactly 200 times, exactly 50 times, or fourth option is close to 50 times but not exactly 50 times. Now here, if you look at the question is saying somebody named Elizabeth is going to flip a coin 100 times, toss a coin 100 times. What is the best definition or best chance or best prediction? Let me read it. What is the best prediction for the number of times that the coin will land tails up? Now, yep. So before Pranav you go, here the question is how or what this question is asking us to answer, or what is the approach that we have to keep in mind. I will let you guys answer it, or maybe let me not jump the gun. Let me hear your answers first. I'll just repeat the question one more time, and Sandin and Sulain, I'll tell you why I'm repeating the question again and again, because that is one of the basic building block of our class. Okay, I'll talk about that, and I know Dikshita is smiling right now. So here the question is that somebody is tossing the coin 100 times. What is the best prediction for the tails coming up? So these are all the options that you see are the possible predictions for the tails to come up out of the 100 time toss of the coin. Now everybody has to give their answers. So first one is exactly 200 times. First one says you will get the tail 200 times. This one says close to 200 times but not exactly 200 times. Third one says exactly 50 times, and fourth one says close to 50 times but not exactly 50 times. Now I want to hear everybody's answer, and I would be more interested to understand why. Yeah.
I got D because A and B can get to 200 because Elizabeth only flipped it 100 times. And
Don't say it loud. I don't want them to hear your answer.
oh, and then I got
And get biased.
And then I got C because it didn't give more clues with probability, so it may be close to 50 times.
Okay. Got one answer. Let's see what Nihan has to say. Yes, Nihan.
I think D too, because like I randomly like marked A and B right off the bat, because like you can't really get 200 times.
Okay. So don't repeat the same thing that Arav said. If you are leaning on D, that's okay. If there is any additional point you want to add, please do so. I'm just trying to save time for everybody and trying to avoid any bias that it would create otherwise. Okay? Is that fine, Nihan?
Yeah.
Yeah, okay. Pranav, is your answer D as well? And you're going to do a copy paste of what Arav said?
No, it's C.
It's C. Okay. That makes it more exciting for me. Okay. Now, I will not ask you why, because that might create confusion for other kids if they have a different point of view. So I'll come back to you. Okay. But Pranav, keep your hands up. I want to talk to you because I want to get that perspective. Okay. Yep.
Okay.
Now let's see what Vasundhara has to say.
I think it's D.
Okay.
Because since there's 2 sides on a coin for head and tails, and there's 100 times, when you divide it by 2, it's about 50, but it could happen, it could land on tails, but it could not too.
Okay. Good. Let's see what Sandrine and Sulin have to say.
I think it's D too.
Okay.
The reason why,
So-
I don't think it's A or B at all, because it's probability. You can't exactly land on edge 200 times. And I also think I just think it's D.
So if you would have done election with C and D, D would have gotten majority this time. Let's see what Dikshita has to say.
I picked D, sir.
You pick D. Same argument like what everybody gave. Okay. How about you, Dokshita?
I think
D. Same reason?
yeah.
Okay. How about you, Ritika?
Yeah, I was gonna say D as well.
Yeah, okay. Okay. Now, anybody in the class who still has a point of view which is different from D, I am still holding Pranav. Not because I'm trying to put him on the spot, I'm just trying to get his perspective, because math is all about the approach that you think. So there could be something important for me also to learn. So that's why I'm trying to get Pranav's perspective as well. And if there's a correction needed on his perspective, we'll do that. Yeah. Yeah, Pranav, over to you. Tell me why you think it would be C.
I think it's C because it can't be A or B because 200 times is, yeah. I think it's C because when you said the question, it said a fair coin.
Yeah. So A and B is out of equation. Now you're contemplating between C and D and you're leaning towards C. So that's what I'm trying to understand, why C, why not D?
Because when you said the question, it said that Elizabeth flipped a fair coin.
Okay. So remember one thing. When you say fair coin, I'm not sure who all has watched the movie Sole. Okay, that's a very old movie. Just before I was born.
My dad watched it.
So that movie had head on both the sides, unfortunately. And that is how one of the leading actor, he used to win all the bets. He will call bets. I mean, he'll call heads, and he'll always win. So that is when you say fair coin, it doesn't give you a guarantee that it will be equally distributed. It just says that the likelihood of both the events are same. So even if you have a fair coin, if you toss it 50 times, that doesn't mean that you will have a 50-50 chance, exactly 50-50 chance for both the scenarios. If it gets to that place, imagine how easy it will be for people to make money by betting in cricket. Yeah, because if you guys don't know, people make millions by, I mean that's not the right way to make money though, but people still do make millions of dollars for betting which team could win for different events. Be it cricket, be it baseball, be it rugby, be it even American football. Once people start guessing the result right, it will become a total mess. And we don't really have to work that hard to make that much money. We can just make one or two solid guesses, make few millions, retire. Done. Yep. So coming back to the point, fair coin doesn't mean that it guarantees you any result. It just says that the likelihood remains the same. Imagine a situation if the coin was little tilted where head comes more often than tail. That is where it is not called fair. Okay. Now the same. I don't think I have any extra speech to give here, but from an approach point of view, you guys nailed it, and the approach that you guys explained it, I'm pretty comfortable with that. What it means here is, in this question, first information that we had. Every question that you come across, right? Always think of that question as your only place where you will get maximum information for solving the problem. So we as individuals get scared by seeing a question, but actually we should be excited by seeing a question. Oh, this is my best opportunity to find all the information for solving this problem. That's how we should look at it. So the question said, Elizabeth is tossing the coin 100 times. If you're tossing it 100 times, by no means you will get more than 100 occurrences of the event. It says, if you're tossing it 100 times, how would you get anything more than 100, be it head or tail? Maximum you can get 100. So these two options are to be ruled out straight away. This is called technique of elimination. When you're dealing with multiple choice questions, there are two ways of solving it. One is you solve it and get the exact answer, or you eliminate the unwanted answers. So this is the elimination technique. You eliminated these two options. Now you have these two options that you want to choose from. And this is an experimental probability case. Even if you don't know which probability case it is, simple thing is, there is no guarantee. Even experiments don't guarantee. That still gives you a chance. So whichever is saying exactly 50 times, this is gamble. You will knock out this guy also. So that is how you will lead on this one. Let's pick one more question, and this time I am assuming I will have less opportunity to speak, because by now at least you will start thinking with a little different approach. Let's look at this question one more time. Second question. Jeremy is going to roll a fair 6-sided die 180 times. Jeremy, that is me, is going to roll a fair 6-sided die 180 times. So I will probably reuse my previous question itself, so that I have to kind of write less. It says Jeremy is going to roll a die with 6-sided, roll a fair 6-sided die 180 times. What is the best prediction for the number of times that Jeremy will roll a number greater than 4? Number greater than 4. It says, what is the best prediction for the number of times that Jeremy will roll a number greater than 4? First one says exactly 30 times. Second one says, this is A. Second one says, this is close to 30 times, but not exactly 30 times.
So like an estimate?
You have to wait, because I have to complete this one. Third one says exactly 60 times. Fourth one says close to 60 times, but not exactly 60 times. So now let me consolidate this question for you guys and read it one more time. It says Jeremy is going to roll a fair 6-sided coin 180 times. 6-sided die 180 times.
Oh, dice.
It's called die. D-I-E. How will you die? Okay. Nobody is dying. Jeremy is not dying 180 times. People can die only one time. So here, so Jeremy is going to roll a die, a fair 6-sided die, 180 times. What is the possibility? What is the best prediction for the number of times that Jeremy will roll a number greater than 4? Number greater than 4, that's the question. Now you guys have this runway to solve this and tell me what is the best prediction. There are 4 options: exactly 30 times, close to 30 but not exactly 30, exactly 60 times. Fourth option is close to 60 but not exactly 60. Which one you think is right and why? I don't get confidence if I don't see anybody using notebook and pencil. Okay? And nobody will give me the whole description, just the answer. I will come to you when I need the explanation part. What is the answer?
B.
C.
Okay, wonderful. Now on the screen, Yadikshita.
C.
Okay, Lakshita. Just the answer. Say that again.
C.
C. How about you, Nihan?
D.
Tanu?
D.
Okay. How about you, Arihan?
D.
Okay. Who has not opened the cards yet? Okay. Yaritika?
I think D as well, but I'm not
Okay.
100% sure yet.
Okay. How about you, Sandin, Celine?
I think it
Also D, but not with D.
I hear two options. Tell both.
D?
D. How about you, Sandrine?
D.
So, with glasses, Sandrine. Without glasses, Celine. Okay,
Yeah.
wonderful. Okay, and I might mess up with the names tomorrow. Don't feel very confident about me. Okay, I have very wonderful memory. Okay, let's go to Pranav. What is the option?
I got D.
You got D. Thanu, you already told your option, right?
Yeah.
Okay. Myra, Myra has to tell something. What is?
Me, but I'm not 100% sure.
You're not sure. That is like playing safe. You guys are
That's peer pressure.
peer pressure. Okay, leave it. So coming back to this question. I got all different options. I got B, I got C, I got D. Thankfully, no A.
Yeah.
At least one is eliminated. So, when I am teaching, when I say clapping, scratching, that gets me distracted. So don't do that. Come back here. So the question is,
180.
Jeremy is rolling the die 180 times. This is one information. What is the possibility or what is the best prediction for Jeremy to get more than 4? Now, before I try solving it for Sandy and insulin only, this is my magic wand for solving any and every math problem. And T stands for trust.
Papa ran.
Shh. This is for the new students.
Do I have to send a message?
This is for the new
So, T stands for trust, meaning when you come across any question, any mathematical problem, any physics problem, whichever problem it is, always trust yourself that okay, if anybody in the world can solve it, that is me. So that is about self-confidence. Keep it with you. Okay? That might sound like a psychological gyan, but keep it with you. Now comes R. Read, read, and read. Read the question as many times you can. Or at least till you are tired or till you are confident that okay, I have understood each and everything that is there in the question. So this is a very important part of solving a problem. Be it a math problem or any problem for that matter. If you don't read the question well, the likelihood of going wrong or the probability of being wrong is more. So when you are not reading, regardless whether it's a probability problem or not, you are getting a probability answer for sure. Then comes A, which is analyze. Once you have read the question, when you have extracted all the information from the question, analyze, meaning you put your thoughts, put your head around it, say okay fine, this is this problem, this is information I have, these are the formulas I know, this is how I'm going to approach solving it. So you have made your blueprint by the time you come to this place. So you trust yourself that if anybody can solve it, I can solve it. That builds your confidence. Read the question as many times till you get all the information, then analyze or make your blueprint for solving it. Then comes N. N stands for Nike. What does Nike say? Just do it. Just do it. So keep aside all the fun part. What I'm trying to say here or convey here is, if you have a math problem to solve or any problem to solve, read the question clearly, make your blueprint, and then you try solving it. Where we go wrong is, as soon as you read the question, you start solving it. That is where most of the problems happen. And that is where we end up scrambling, we end up redoing it, we find more problems. So if you read the question clearly, 1 time, 2 times, 3 times, analyze, and then you do it, you will find it more on the right side when it comes to getting the answer. And another trick to remember is, if you read the question, just try experiencing it yourself. Any question that you pick up, try solving it by reading it once versus try solving it after reading it 3 times. You will see that second attempt, when you made after reading a couple of times, the question became much easier, much simpler to solve. Okay? Reading makes the question much lighter in nature. Now coming back to this one. So that's the reason why you guys would have thought why this old man is reading the question so many times. My intent was to make it lighter for myself. Because you guys might be very intelligent, I'm not. Okay? So that's why I was reading the question so many times so that it becomes easy and matches with my, the way my antenna works. Okay? Alright. So coming back to the serious point. So now you know Jeremy is rolling the die 180 times, and we're trying to find out what is the best prediction for a number greater than 4. Greater than 4, there is no greater than equal to. So we are only talking about 5 and 6. Now, First of all, I will use my elimination technique. There is no guarantee in the probability world. If there is a guarantee, that means it is fixed. So this one and this one, I will simply rule out. Anything that says exactly, I will rule it out. Now, when I'm rolling it 180 times, I can get 1 to 6. In the most ideal scenario, I will get 5 1/6 of the times, which is 1/6 of 180, that is 30. And I can get 6 also 1/6 of the time, which is 30 out of 180. So total I'm talking about 30 plus 30. In the most ideal world, which doesn't happen though, there is no guarantee around it. I'm only talking about 5 and 6. 5 can come 30 times, which is 1/6 of this whole number of occurrence. And 6 also can come that many times. So 30 plus 30 is 60. So total number of possible occurrences up to 60, but there is no guarantee. That's what this option says. That's why I will go to D. I will rule out D also. Because 30 is there is no correlation here. We have to look at two numbers. Every number can come equal number of times in the most ideal state. So 30 out of 180. 30 out of 180 for this guy, 30 out of 180 for this guy. So 30 plus 30 makes it 60. My only option is D. Now I want to hear all of you who got a different answer and who are still not convinced about why I am saying 60. And it's okay. I might go wrong as well, only with the valid argument.
So it's a prediction?
This was a prediction only.
Oh, so this was experimental.
Experimental probability. But even if you forget about what is that term experimental probability, you don't have to think about it. This just says that you have a situation, you are doing experiment, what is the possibility you are looking at? Does it make sense to everybody or it only makes sense to me?
It makes sense.
Let me call out the names to put everybody on the spot. Sandrine, Suleen, does it make sense, beta? Okay. How about you, Lakshita, Ritika, said thumbs up. Arihan,
Yeah, makes sense.
convincing enough?
Yeah.
If you come across similar problem, would you use similar elimination technique and approach? Shh.
I mean, we do that in school.
Yeah. Okay. How about you, Thanu? Convinced? Pranav?
Yeah.
No doubt about how your teacher forced you to believe this?
Yes.
Okay. Alright. Myra? We'll take it offline. Okay. Okay. Alright. So everybody is with me? So this was all with respect to experimental probability. If I say that we'll have 2 more classes to talk about experimental probability concepts, I'll be actually wasting your time. I'll not do that. So the only thing that we wanted to kind of touch upon was that what is the difference between probability and experimental probability. And experimental probability is nothing but a different flavor of probability where you don't go by the mathematical concepts, you go by the actual data and take an average out, and based on that you extrapolate to derive the probability. Make sense? Smarni, okay?
Yeah.
So this is what AI does. See you guys tomorrow same time. Alright?
Yes.
Nice, sir.
Alright, bye bye, take care.
Bye,
Bye bye, bye bye.
Bye, sir.
Bye bye, bye bye.